Okay, so we're back in section 4.2, video part 2, and looking at the region under a curve from A to B. So if we consider our subinterval delta x is b minus a over n, and then x sub I is equal to a plus I times delta x still, then the area is the limit as n goes to infinity of the summation from I is equal to 1 to n of f of x sub I delta x, and that is in fact equal to the integral, to find the region under the curve. So we're looking at the theory behind the definite integral here. So the interval divided into subintervals, if we look at the interval from A to B is divided into n subintervals, the width of each subinterval then would be b minus a over n. Now the lower sum, you can see that that f of lowercase m sub I, that gives you the lowest height of each rectangle, and then f of capital M sub I gives you the maximum height of each of the rectangles. So where you would have the lowercase m would produce inscribed rectangles for that area and the summation of the area, where the capital M would produce the circumscribed rectangles for the area going outside of the function or above the function or below the function. It happens to be below the x-axis. So not a hugely different topic than what we've been talking about with left and right. And it's easiest to talk about this on a monotonic function that is either only increasing or only decreasing. So it's easy to picture with this. Okay, so finding upper and lower sums for a region, here you're going to start off and you're going to say, okay, well here they have the function x squared and increasing, it's only increasing. So the left endpoints, that's going to produce an underestimate. And we can see by looking at the graph, and we can get used to saying this, things like this over and over again. It's a topic where they often ask about, will the Riemann sum produce an under and overestimate? Okay, so we have delta x first, and then we look, we have the interval from 0 to 2. So it's just going to be 2 minus 0 over n in this case, okay? So it's equal to 2 over n. And we're using left-hand endpoints. So m sub I is going to be where you start plus you're going to have an I minus 1 for your counter, and then it's going to be times delta x, which is 2 over n. So we end up with just that last part, 2, and we can rewrite that as 2 over n, and then just times the I minus 1 if you wanted to in the summation, whatever's easiest. Okay, so for this one, we have the summation, then here, lowercase s, summation, lower sum. And so we're using left endpoints, but this is the lower sum notation. And so then we're just going to put this in, then I'm going to go this way with it. And I is equal to 1 to n of, and I'm going to say this as f of 2 times I minus 1, and then that's over n. So I'm going to put that value of m sub I into the function, and then I'm going to multiply it times delta x, which is times 2 over n. Okay. So when you're working with this, you can pull the 2 over n out front, but I'm going to wait until I get done with the function here. So I'm going to move over here to the left, and I'm going to say, all right, then that, moving right here. So then that's going to give me, the function itself is x squared. So I'm going to go ahead and replace this functional notation with the actual function. So now I have it's equal to the summation from I is equal to 1 to n of f of 2 times the quantity I minus 1 over n. So I'm going to do that as 2 times I minus 1 over n, and then that's going to be squared. That represents the function x squared, right? And then I'm going to put in that 2 over n. Okay. Now I'm going to do a little bit of algebra here with this one. So this is going to give me the summation, and I want to get an expression. I know that we're going from 0 to 2, and we could say what delta x is, but we're just doing this as a representative. We have 4 rectangles in there, but I want to do this as a representation and not say that n is equal to 4 there, okay? So we have the summation from I is equal to 1 to n. So what I'm going to do is I'm going to square 2 and n in this. So I'm going to get 4 over n squared. And then I've got this I squared minus 2i plus 1. And then it's times this 2 over n here. So then this is equal to, then I end up with 4 over n cubed times 2 over n. So what I'm going to do is I'm going to bring out the 8, an 8 over n cubed. And you can see where you progress here to your summations of I squared, I, and so forth. So I have 8 over n cubed times, then it's just the I squared that's going to stand alone, the summation of, and I think I'm just going to leave that right like that. And then it's a summation of I squared from I is equal to 1 to n minus the summation of 2i, because I've already got this. See if you pay attention here and here. I've already got those combined to the 8 over n cubed. So then I have a minus the summation of 2i from I is equal to 1 to n. And then I have a plus the summation of 1. And very often I like to leave the 1 in there, even though it's, because to just say the summation from I is equal to 1 to n without any number in there, even though it's, you really want the 1 in there to clarify what are you adding. Okay, and so with that, then I could take it one step further. I'm going to move this down. So then we have this 8 over n cubed, 8 over n cubed, and you can see where, cubed. So the I squared goes in, and you have this n times n plus 1 times 2n plus 1 over 6. That's going to replace that first summation of I cubed. And then after that, you have this minus 2, and then you're going to have the n times n plus 1. It's a 2i, right? So over 2. So the 2's are going to cancel there then, right? And then you've got this plus n. Okay? Okay, now, so what you're going to do is you're going to simplify this, right? So this lower sum, I'm going to scooch this down a little bit here because I do have a little extra room for the right endpoints. So what you're going to, I'm going to do a dot, dot, dot. You're going to end up with this. It's going to be 8/3. You're going to do a little simplifying. Minus 4 over n. You're going to get plus 4 over n. Sorry, 4 over 3n squared. Okay, so this is your lower sum. So take that down. That's your lower sum. Okay. Now, to get the upper sum, it's kind of interesting because you'll see a little bit of symmetry ideas here. Okay, now we're going to do the same thing here for the upper sum. We're using the right-hand endpoints, right? So we have the same delta x, right? We still have this 2 minus 0 over n, or we have this 2 over n, okay? Now, we need the m sub I. M sub I is going to be where you start, plus now it's going to be I times 2 over n, okay? The I times, so we're going to end up with 2i over n. Now keep in mind, our function is the same, it's x squared. So this is kind of a nice little, that's what I love right-hand endpoints. When you have that I minus 1, it's just a little irritating. It makes it so much harder when it can be so much easier. So this is a capital S here, and a capital S sub n. So that would be the summation. Now we're using the capital M expression for this I is equal to 1 to n. And so f of m, we're just going to put this in here then as our 2i over n, and that'll be squared. There's our function squared. And then we need to multiply that by 2 over n. And there's our summation. Okay, so what we can do is we can pass through all of the things that we know here. Let's just do it down here. So we then have the summation. And so it goes from I is equal to 1 to n. And then, of course, we're going to have that same 8 over n cubed. So we have the 8 over n cubed, right? Because we're going to have 4, 2 squared is 4, n squared over n squared, and then it's times 2 over n. So we're going to end up with this, I squared. So we have 4 over n cubed times I squared. So then this is then going to become 8 over, n 8 over n cubed. And then times I squared is just going to be n times n plus 1 times 2n plus 1 over 6. Okay. It kind of becomes artistic. Mathematics is very artistic. And once you get into it and you develop your techniques and being very careful with it and making sure that everything is recorded as if it was a kind of like a lab manual. Okay, so, but instead of continuing on with this, what I'm going to do is we're going to combine these, and here's what you're going to get for an answer here. So here, where I said the lower sum, here's the upper sum then. And this is the upper sum. We have the right-hand endpoints here. So that's, of course, going to give us the maximum value on the interval. So then for the upper sum, then that's going to be 8/3. And that's going to be plus 4 over n. And then it turns out to be plus 4 over 3n squared. You can kind of see you're thinking to yourself, man, what if n goes to infinity with these two expressions, upper and lower sum? And you're probably thinking correctly that the value has to be 8/3. I think my pen is running out of juice here, so I might have to stop and start over again. Okay, so I'm going to have to stop after this video, but you can kind of see where we get 8/3 minus 4 over n plus 4 over 3n squared. And the only difference between the lower sum and the upper sum really is that middle term. And you can kind of say, this area is going to be 8/3, because if n goes to infinity, the exact answer has to be that, which it is. But so kind of interesting discussion of nomenclature and making sure that you understand what you're reading when you see expressions that I'm using in this lesson. Okay, so I'll be back in the next video, and I'll pick up with example 5. So that will be video 3.